Ladies and gentlemen, at first I would like to introduce myself. My name is Marcin and together with my colleague Lukasz PASKO, we have prepared the paper entitled Customer Trust versus Retailer Profit, a case study on optimizing base stock level using multi-agent based simulation. We are working in Department of Computer Science in the Faculty of Mechanical Engineering and Aeronautics in Rzeszów University of Technology. At first, I would like to share with you some motivations according to the chosen topic of our research. The concept of the presented research was connected to the lockdowns under COVID-19 pandemic. In that situation, the supply chains were unable to work to deliver products or services to the final customers. As a result, the final customers was unable to buy products or services which they want at their typical supplier and was forced to look for other source of delivery. What is more, the switch from one supplier to another one could be continued even after lockdown was removed because of the customers' new habits. So, during our research, we was especially interested in the issue connected to the trust which occurs between the final customer and selected retailer, and how proper managing of base stock level influence. Based on the motivations, the three research questions have been formulated. The first one, how different levels of base stock influence the generated retailer's net profit, as well as the trust level in the customer's population. The second one, if modeling and simulation help to find the optimal cost balance between generated storage costs and costs due to the lost sales and customer churn. And the last one, if using the NetLogo software gives a possibility to create software tool elastic enough to incorporate some new insight to the basic simulation model to discover new analysis perspectives. Because the paper is focused on research on base stock level and customer's trust level, I would like to very shortly define these two terms. Base stock level is one of stock policy parameters which allows the retailer to set the threshold which is used to compare to current product stock level. If the current product stock level is lower than the base stock level, the delivery of products is made. The research was conducted according to the case study. The main assumptions in the case study were as follows. First, the retailer sells products to the final customers and only one type of product is considered. The initial stock of products is 13 pieces, and the final price of the one piece of product is equal to $150. The production costs of the one piece of product are estimated at 70% of the final price. The retailer needs also to cover storage costs not included in production cost, and here we have fixed cost where $8.31 per 1 square feet per year is needed, and one piece of product requires 10.5 square feet. And the variable cost, which is estimated to 3.18 per day per one piece. The retailer's sales data shows the number of served customers varies from 50 to 110 per month, and the product's average sales is 7.5 pieces per day. And the last assumption in case study, if the customer is able to make successful purchase at the retailer, his satisfaction rises average by 2.5 points on a 10-point scale as customer surveys reported. According to the case study, the retailer formulated the problem to solve. How to choose the optimal level of base stock that will enable the maximization of the net profit achieved by the retailer. Of course, there is need to define optimal. In the case, based on the formulated case study description, the model assumption and characteristics have been established. The main assumptions of the model are as follows. According to the case study, we are interested in the whole population of customers where their trust needs to be monitored, so we have chosen the multi-agent based modeling metaphor. Because of the formulated problem and to create the solution flexible enough, we have decided to create simulation tool equipped with graphical user interface to give potential users of the tool comfortable way to incorporate changes in the simulation and model parameters. Because of limited time of my speech, I would like to only show main and basic characteristics of the model. The single simulation cycle represents one business day. During each simulation cycle, customers in population can decide on its own if they want to make purchase. The results of that action will affect their trust to the retailer. In the system, there is also one agent who represents the retailer. He sells products to the customers, monitors revenues and costs, and replenishes the stock of products. All parameters. According to the description of the problem in the case study and proposed model characteristics, the following set of metrics were established. Total and daily number of complete orders by the retailer. Total number of orders realized by the competitors. Percentage of completed orders by the retailer. Total number of product out of stock situation. Total number of deliveries made to replenish the current stock level to achieve the base stock level. Daily and current level of products. Daily and total profit generated from sales. Daily and total storage cost. Daily and total net profit or loss, daily and current average customer trust level. The most important are two last metrics, which allow to provide direct answer which tested base stock level is the optimal one. Because the conducted research was our first according to the area of interest, some model specifications have been incorporated to our simulation model. Deliveries ordered at the end of a given business day are available to the retailer at the beginning of the next business day, so we can tell they are instant. The costs of delivering products do not affect the retailer profit. It is simply omitted in the current version of the model. The products offered by the retailer and its competitors are homogeneous to each other, also in terms of price. So, there is no difference the customer buys the product at retailer or its competitors. All sales transactions concern one unit of a product. Products are sold to customers by one unit per one business day. The way the model is run under simulation engine is described in the following scheme. There are four main activities at this level. First is connected with simulation engine initialization, where global variables are initialized, and the current simulation cycle is set up to 0, and some information about the experiment are printed in the console window. The next activities are connected with creating the whole population of customers agent type. Here the appropriate icon is set, the visual position of the agent is drawn, and its initial trust level is set up. Then, according to the customer's current trust level, its icon is marked with specific color. It is important to notice that all these activities are conducted to every customer in the population. Similar activities are performed in the single retailer agent. Last and the most complex activity. What exactly happens when the simulation is run? It is depicted in the following diagram. Because it is quite complex, only main elements are worth to notice. First, there is a checking condition against end of simulation. If there is not the case, global metrics are zeroing and further actions are conducted. Next, all customers start with their actions, and there are four main blocks of actions. First, there is a simulation if the customer wants to buy a product at the current business day. Next, there is a check if the current customer's trust to the retailer is high enough to make the purchase at the retailer. If no, competitors fulfill the transaction. Next is sales transaction, if there is a product available at the retailer's stock. If yes, the stock decreases and trust to the retailer is going higher. Otherwise, the out-of-stock problem is counted and the customer trust decreases. Final activities in the customer agents are connected to the change the color icon according to the current trust level of the customer. The customer's trust is aggregated in one of global variable. The almost last group of activities is connected to the retailer and delivery of products if the current product stock level is lower than proposed base stock level. Last activities move. The developed tool graphical user interface is presented in the picture. It contains a few sections which allow the user of the tool to select duration of the simulation and to reset and to start or stop the simulation engine. Next section allows to set various parameters according to the population of the customers, like the number of customers, probability of making order in the current cycle, and trust reaction to different market events. Another section generates information in the console window, as well as shows values of the metrics during and after simulation will stop. Next section provides visualization of the system in terms of customers which have different colors according to their current trust level. Another section allows the user to set various parameters connected to the retailer's stock policy, like tested in that case base stock level. And the last section considers by using the proposed simulation model equipped with presented graphical user interface, the experimental research according to the case study was conducted. During the simulation experiment, proposed base stock level values were tested. The proposed values are shown in the slide. Because the probability distribution was involved in the simulation experiment, every proposed base stock level value was used in the 5 different simulation runs to realize distribution and to generate more stable results. In total, 80 simulation runs were performed. After each simulation run, all presented metrics were gathered and analyzed. But to solve the problem described in the case study, the graph has been prepared. The graph shows dependency between the generated net profit of the retailer according to the different values of base stock. The analysis here is quite simple. It is easy to notice that the maximum net profit of the retailer is reached if the base stock level size is equal to 13 pieces. Someone can ask why the higher level of the base stock level does not bring higher net profit as marked on the figure. It is because of the market saturation. The customer population is limited, and offering more products from the retailer causes no bigger sales, but based on the previous result, we have the potential solution. But we need to check if it is alright according to the second crucial metric, which is customer average trust. To answer, the following table was prepared. In the table, we listed all checked base stock levels and calculate average trust in the customer population for each simulation run. It is worth to mention that threshold value set by decision maker was 95%. We can see that the best possible base stock level according to the average trust is equal to 20 pieces, where minimum and average trust from 5 runs is equal to 100%. But as we remember last figure, that base stock level generates lower net profit than proposed level of 13 pieces. So, should we stay on base stock level equal to 13? If we take under consideration net profit only, the answer is obvious. But also, in terms of customer trust level, the 13 pieces generates average customer trust level equal to 99.31%, what is higher than proposed threshold. Besides, also minimum average level. After the research was complete, we have formulated some final conclusions. The developed multi-agent-based simulation tool in the NetLogo environment gave us the possibility to simulate and analyze the relationship which occurred in our mini supply chain model. It was successful to find the optimal product stock level at the retailer according to the two main metrics, the retailer's net profit as well as customers' trust level. It is worth to mention that both metrics are consistent to each other, but only in specific range. What is more, incorporating other metrics gives the possibility to perform additional analysis connected to issues interested to the decision maker, like availability of the products, number of generated out-of-stock problems, or generated storage costs. We are going to extend the proposed model in the further research, which are focused on introduction of the delivery time in the model, selecting the optimal batch size, and to calculate delivery costs connected to the deliveries. We suppose that incorporating those factors in the simulation model makes it more realistic and reliable. So I hope you enjoyed the presentation. Thank you for your attention. Goodbye.